All right. Math 21, we're hitting 3.1 and, or not 3.1, 3.4, which is measures of position and outliers. And 3.5 will be the 5-number summary and box plot. I want to remind you guys about the empirical rule again. This is where we had a bell curve. That's a pretty good bell curve. It's a little tall on the right, but looking pretty good. Maybe it goes a little bit lower over here. There you go. In the middle, we have a mean. And when you go down to where it's about half the hill height on each side, that's plus 1 standard deviation or minus 1 standard deviation. And then you try to do the same spacing for 2 and 3. Remember, mu is mean and sigma is standard deviation. And we'll be doing some examples here with numbers, so I'm not gonna list the IQ ones again. But let's go with like male height. Male height. The average, at least in the US, is 70 inches. I know this is in the US because it's using inches. And the rest of the world uses fucking centimeters. So. And standard deviation is 4 inches. So that makes this number here in the middle 70. And I add 4 each time I go to the right. And I subtract 4 each time I go to the left. Now, Hefe's height. I'm a good 5 foot, 5.5 inches. I need that extra half inch because I'm short and it fucking matters. When you're short, it matters. If I wanted to convert that into inches, 5 feet times 12 will give me 60 inches, and then I add the 5.5. And I get 65.5 inches. Hefe is over here. Right below this motherfucker. That is a way of measuring my position within all of the male categories. This measured my position. But that's a little pain in the ass to look at it, and it isn't all that. Like, it's clear I'm below the halfway mark. But like, where am I after that? As a reminder, these categories, I should have done this earlier. Fuck. This will take a good 45 seconds to repower up. Cause it won't let me hit power on until it fucking says, fuck off, JD. There it goes. Wasn't that fun? Alright, I'm gonna put little dashes here. Cause there was more to remember with this table. Each of these were 34%. Then each of these was 13.5%. Two 2.35% for the third bracket out. And 0.15% for everything after 3 deviations. Now, this is a little depressing here. Because if I add up these first 3 columns. These first 3 columns, 0.15 plus 2.35. Plus 13.5 is only 16%. And I am below that mark, which means I am in the shortest 16% of males in the US. That makes me feel little. That's why that extra half inch fucking matters. Now, we all know. And nobody likes it because we're trying to treat everyone as equal, but females have a different information on them. Female height, at least this was when I wrote this all down, the average was 65 inches. With a standard deviation of 3.5 inches. So not only is their mean different, it's lower and their standard deviation is lower. It's kind of like hard to measure where I compare to say maybe Bianca in the female category. How tall are you, Bianca? 5'2.5". Excellent, you're short as well. We're gonna use you. So Bianca, if you don't mind, are you okay with that?
Yeah.
Bianca is at 2.5. So if I convert this to inches, it's got the same thing I had, 60 inches. Now plus 2.5 inches, she's at 62.5. So clearly, she's shorter than me. But she is on a different curve. So maybe she's not in the bottom 16% like David is. God, that's disappointing to look at. That makes me feel so short. That's fucking rough. Bottom 16%, Jesus. So when we have, she's on a different bell curve though. So how do I compare people from different categories? Do we compare positions? From different groups and. Different groups with different means deviations. It's called the Z-score. We're gonna come up with something called the Z-score. And one time to finish writing this page before we switch over. People are still writing, giving them time. The homework that was due today, I extended to the 17th. Not because you needed it, because you had all last week off to get caught up, but. Apparently, some of you need it, because some of you haven't done a goddamn thing yet. Some of you are gonna have a really hard semester if you're trying to get caught up and hoping, praying that I extend homework due dates. Because like, if you don't learn how to do the stuff on the computer now, the midterm's on the computer. You have to know how to use StackPunch and do that shit. And the homework's also part of your grade. So if you're not doing the homework, you're gonna fucking tank the midterm, and there goes 40% of your grade. And you can't get a C in this class if you don't do the homework and fail the midterm. You can't pass, so. Start doing the homework. Some of you have, two of you have your. Access expiring today, because you had temporary access, you do need to buy the textbook, it's cheapest through the website. You can get it from the bookstore by getting the MyLab thing for stats. And using the access code, but it is cheaper online. And then I think 8 of you are already expired. So you want to do that soon. Alright, everybody looks like they're done, so let's talk about Z-score. My score, I said my score was 65.5. I can relate this somehow to. I'm gonna call that X. I can relate this somehow to the mean. Plus some multiplier on sigma, and I don't know what it is, we call that multiplier Z. So my Z-score is 65.5 equals 70 plus Z times 4. And I can calculate what Z is using some algebra here, but generally, we don't start in this form. What we do is we solve for Z here. So if I subtract the mean from both sides. I have X minus mu equals Z sigma. And then I divide both sides by sigma to get Z by itself. I get Z equals X minus mu over sigma. That is how we calculate Z-scores. Yes. Because it's gonna allow us to compare things in different categories. Like, I know I'm in the bottom 16% just by looking at the empirical rule. But I didn't check where yours was at, but if you were in that range, like, you might be just a little bit under, and like, which one of us is taller relative to the rest of our gender? Assuming you associate with the female gender, I assumed you did, that's a big assumption. So, let's calculate head base. My X is for the individual score. And we've already identified mean and standard deviation, the other ones we know. So for Hefe. My Z score is 65.5. Minus 70 divided by 4. And Bianca's. Z score, we'll say ZJ and ZB. Hers was 62.5, that was her height. Minus her group's standard deviation, which was mean was 65. Over her standard deviation was 3.5. Mine is negative 4.5 over 4. Hers looks like negative 2.5 over 3.5. It looks like Anta could shorten. I'm getting negative 1.125 for me. And for her. Negative to 3 decimal places, 0.714. So what this means is like, if we make a bell curve with z-scores. I'll do a z-score bell curve. In the middle is 0. And you just do whole numbers left and right, it makes it really easy. The z-score is easily set up. But Hefe is right here. And Bianca is, she hasn't gone below -1, so she's to the right of it. Bianca is right here. So on our, and then this allows us to overlap like bell curves to see respectively who's, in this case, taller, since it was a measure of height, who's taller with respect to the rest of the people in her or his population. She's taller. Even though she's taller with regard to women, even though I'm taller than her by 3 inches. Does that make sense? That's why we do it, allows us to compare apples to oranges, things in different categories. Let's see. And we like to use this as a measure of position. The z-score is how we do measure of position for bell curves. With bell curve data. Normally distributed data is the word they like to use. But normally distributed makes a bell curve and it takes a hell of a lot longer to say normally distributed. You have a question, Emma?
Yeah, where did the 65 come from?
65.5 is my height in inches.
No, on score B. From 62.
That is the female average height. On the previous page, I wrote it right here, those two.
Oh, okay, because I was just going based off the.
We gotta use the numbers from our own categories, that way we can effectively compare.
How would you write that? Like, that she's taller than, say like statistically, Young was taller. Is that the correct way to say it?
I would say this, I wouldn't say it statistically. I would go, well. Uh,
I do.
I don't wanna be up, right, the best way to say it is. Bianca is. Taller. In proportion to women. Than David is with men. No, not me. I almost fucking wrote it again. I wrote write means so often in this class, it's weird to write men. If we turned it around and said shorter, we'd have to put me first. You know what, I like that, sorry Bianca, you're out of luck. David is. She got to go first. On the first one. Not inclusive is like the whole height category in general. Since people are on a spectrum of testosterone and estrogen levels. Really using male and female standard deviations and means. Ineffective. Yeah,
Say like David is below average and
or David is more below average than Bianca, because you're below average too. We both have negative scores. But I am more below average. Yeah. She's just gonna throw me under the bus and not have her in there. David's below average, and there was nothing in there about Bianca. We're both below average, that's what a Z-score, negative Z-score tells us. Z-score that is less than 0 or negative. Means you're below average. And it tells you how much below average. And Z-score greater than 0, obviously. Would tell you, these are positive values. That you are above average. And how much above? But it is using that bell curve. So like going from 0 to 1. You're like in the top 50 plus 34%. If you have a Z-score over 1, you're in the top or you're above 84%. If you have a Z-score of 2, it doesn't add a whole lot more, it only has another 13.5%. A Z-score over 2. Let me write these. A Z-score equal to 1. Means you're taller or more than. That is 84% of the population. Z equals 2, only adds another 13.5%. Which raises us up to 97.5. Now that is a big number, if you've got a Z-score above 2. This is like if you're measuring IQ, you're in like Mensa category people. And I don't think I'm in there. As much as I thought I was, I think when I took the IQ test, it told me, no, you're not as smart as you think you are. But Z equals 0 is 50%. So like, as you go up in Z-score. It's not the same percentage, this is an increase of 34%. This is an increase of only 13.5%. So it's not like an even measurement. But it does give us a way of comparing different groups. For skewed data, we gotta do something different. graphs where it looks like this, it's like that, or we got one that's tall on the right, but not on the left. We don't wanna use mean and standard deviation, because they're not good reflections of the average kind of thing. Here, we like to use something called the median and IQR. IQR, median we've already talked about. IQR stands for interquartile range. And we calculate it by doing Q3 minus Q1. And if you were in the 321 class, when we had the stack punch up, you saw Q3 and Q1 on the list. So to like kind of go over what Q3 and Q1 are, I need to talk about what percentiles are. This leads us to percentiles. Which will go on another page. About half the time I do that lecture, I have a Z-score larger than the female. And the other half, like today, is lower. Kind of weird, like I just, because I'm picking people based on their height sitting down. When you're sitting down, it's the great equalizer. How do I know? I play D&D with guys that are all fucking 67 inches taller than me. But when we're sitting down, you don't notice a height difference. It's only when we go out, like we're standing in line somewhere, that I'm fucking doing this to talk to them. No one looks like they're writing, so we're good to go. Let's go to percentiles. Percentile is the value that a score represents which reflects the percentage individuals, I'm gonna say individuals, not people, because it doesn't have to be people. But individual objects, things like that, individuals that have a lower value. So remember when I just got done saying like Z0 is equals 0 was 50%. Z1 z equals 1 was 84%. Z equals 2 is 97.5%. These are all percentiles. It represents the amount of population below it. Percentage of individuals with a lower score. Now, SATs, there's a lot of tests in high school, like SAT, I think the ACT, I don't remember what ACT stands for. They often do percentiles. And it's usually with, I know that if you wanna go to grad school, you'll take the GRE which is a graduate requirement examination. They measure in percentiles only of people that took the exact same test. And they give a specific test throughout the nation at the same time. The same day, and then the next test, even if it's 3 hours later. Is a completely different test, because. By that time, someone could have like finished the test and went and given answers out. So to prevent cheating, the questions are completely different every time. And to make it so you're not comparing people on different tests. Each percentile is only on its own grouping. Having a 99 percentile means you're like the top 1%, everybody's below you. That's a pretty good spot to be in. Unless it's like number of murders. There are categories that like you do not want to be in the top 1%. Yeah. But in general, that's what it means. And quartiles. Are percentiles in increments of 25. We have 0%, 25%. 50%. 75%. And 100%. None are lower, none are higher, no percentages are higher, percentiles higher or lower. Cause you can't have 101% of the population below you. You can only be the top. These have names. This is called the min. It's the lowest score. 100% is the max or maximum score. 50% you already know the word for, median. And for 25%, we use Q1. And for 75%, we use Q3. Which stands for first quartile and third quartile. This is our 5-number summary. This lecture kind of blurs in 3.4 and 3.5 together. I don't know why they're separate. It's kind of like one topic. The only one that's a little different is the box plot if you're doing it by hand. We'll talk about how to do it. So I said when we're using skewed data, we're using median and IQR. And that's Q3 minus Q1. These are scores. Because if we're dealing with stuff like this, there's a mean and median are both, you can't do a median on a color. They're all quantitative data, so there's a numerical value to each of these. This represents the inner 50% of data. And it tells us how wide that is. How wide that 50% region is. And this is effectively our way of measuring dispersion on skewed data, where in the bell curve, we use standard deviation for spread or dispersion. or how spread out the data is. And all of our 5-number summary. Just like mean, median, standard deviation, this is available in StatCrunch. Under stats. Summary stats. Columns. And we'll go do examples with this in a little bit. So in bell curves or normal distributions. Z tells us our position in the group. Are you king of the castle? Are you the top 100%? Are you the alpha? You got the highest Z score in the group. In skewed data. Your percentile score does the same thing. Covers position. Anyone watching the debate tonight? I don't wanna see the shit show. I know it's gonna be a shit show. It's not gonna be pretty. But I kinda wanna see it.
Do you see? The documentary, like she made this whole like.
Did. I saw Colbert yesterday. I was watching it today from last night. Colbert had trumped something Trump said in a recent rally. That Kamala wants to allow schools to steal your children. Do gender surgery on them and then give them back to you. If I could, this was not a, like, there's no way to misunderstand it. He said it like over a 45 seconds. Uninterrupted, like, description of how they're gonna take your kids, they're gonna send them off to a hospital to get surgery. And your little poor Jimmy's gonna come back as, you know, like a Jane. I'm like, what the, where the fuck are you getting this? What, can I have some of whatever you're fucking smoking? Cause that shit's good stuff. No one's like fucking forcing anyone to get a gender. They don't even do that shit on Saw. That's like worse than Saw. You know what I mean? That's some, I don't know where you even came on, this is some next level shit. But it's like not something you could misinterpret, like it was like. Like when you talk about, can we inject bleach? Would that get rid of the virus? I was like, no, you didn't. Sometimes you gotta run this shit by other people before you say it out loud, bro. You really got it. Alright, so. There's something else when you are the leader of the pack or the runt kind of thing. You're an outlier or can be an outlier. So we need to talk about outliers. Outliers are either and we mentioned them before, have scores that are much larger or much lower than most of the population. Elon Musk is an outlier for income. He makes a lot of motherfucking money. So when we're gonna talk about outliers, we've got two different data sets to do this in. In our bell curve set. We just do either z is less than -2 or z is greater than +2. And for skew data. We do outside the fences. And I haven't told you what a fence is yet, so no, you shouldn't know yet. So in skewed data, we will have a lower fence. And we will have an upper fence. The lower fence is calculated by taking Q1 and subtracting 1.5 times the IQR. So we figure out where the 25% mark is. We've used IQR to like measure like spread, and we go, if we're a lot further lower than that, you're an outlier. Upper fence is similar, but we do Q3 plus 1.5 IQR. Most and sometimes all scores are between the lower fence and upper fence. So here, outside the fences means a score. Outlier here. Is a score lower than the lower fence. Which I'm gonna just start calling LF. Or greater than the upper fence. And I'm gonna use UF for that. Conveniently for the SKU data, everything is in StatCrunch. Stats, well, almost everything, it doesn't have the fences there. Not on summary stats at least. We can get the min, Q1, Q or median. Q3, max. And even IQR there. The fences, if you wanna see the fences show up on a box plot. And it's been almost an hour, let's take a 10-minute break. We'll talk about how to do a box plot. We'll do one on StatCrunch, we'll do it by hand too. I wrote this data set down, it's what I'm gonna go pull up in StatCrunch in a second to show you guys how to do this. We'll record those numbers I was talking about, and then we'll come back over here to do a box plot, show you how to do it before we look at the official one. So. Let's see. I need to do stop or share. Change over to that screen while I'm doing this. So if you're in Canvas, you can click on StatCrunch. Visit the StatCrunch website. If you do data sets, you can type in what I had there, Math 21, student survey, spring SPR 2020, Pepe. For those of you that are working along, I will wait and give you a chance to do it. That way you can pull the data and follow through on your, yeah. It is over here on the left on the drop down. Like StatCrunch.
How did you guys do that page?
That's where you.
Oh,
This is the homework,
that website.
yeah. And that's the name of the data set. And this is what we have here. Age has a good range. Let's take a look at doing this with age. So stats, summary stats columns. I'm gonna do age. And I'm gonna see what it comes with. Age comes with min, max, Q1, Q3, median. It doesn't have an IQR, but we can calculate it. I can also go back in and select these where they're in the right order. So I can scroll down and click on min. And then scroll down, hold down control and click Q1. Let go of control, go find median, or command key on Apple, I think. Median and Q3 and max are right here. And IQR is further down the list down there. So if I do this, I can have the 5 values here. Do I see any scores on this list greater than? Oh wait, we haven't calculated the fences yet, and I'm sure the fences are gonna be. We'll have things outside the fence. I know the max is outside the fence. So let's write those numbers down. So age column. I know you can't see what I'm writing, but I'm leaving it up on the screen so people can see it. Alright, so that's what we have. This is our 5-number summary. Let's see. And let's take a look at calculating the lower fence and upper fence. Because I gave the formula earlier, but we haven't done it with an example yet. This was Q1 minus 1.5 times IQR. And the upper fence, I'm gonna give myself a little bit of space. Just writing down the formulas real quick, Q3 plus 1.5 times IQR. So IQR is Q3 minus Q1, those are the 75th percentile minus the 25th percentile. StatCrunch gave it to us as 4, and we can see that is true, this is 23 minus 19 equals 4. If I wanna do 1.5 times IQR, it's gonna show up on both of them. I might as well do it now. 1.5 times 4 should give us 6 if you do that in a calculator. So. Q1 was 19. We're gonna subtract 6, because that's 1.5 IQR. My lower fence is at 13. Scores below this are outliers. The min was 18 though. Which means there's none here, none in this range. If I do Q3 plus 1.5 IQR, Q3 was 23. And I add 6, I've got 29. Scores above this are outliers. And our max was 51. So there's at least one. So at this point, I'm gonna go back. I'm gonna go back and find them. Go find and list the outliers. To help me, I'm gonna do data. I know there's a sort command. And we'll look at the screen on how to do it when we get there. I remember the command sequence somewhere there. But we can tell it to sort all the columns by age. And I'll probably do it in descending value by age. That way it puts all the highest numbers at top. Highest age is at top, so they're easy to find. All right. Let's tab over and do that. Gotta do the camera on this as well at the same time. I can do data sort is down here. And I want it to sort all columns. And I want it to sort by age. And I want to do it descending. And I'll say replace current columns, that way it's not filling up the data table. Or I can do open a new data table, that's fun, let's do that. Oh, it clearly didn't, it fucked that up, because someone typed 20 rather than 20 years old, but we have a lot of them that are over 29. We've got 51, I'm gonna write down a list of these. 51, 42, 38. I've got 37 times 3 of them. 35 times 2 of them. We've got a 32 and a 30. And I'm going to show you this is a skewed data set by doing a graph of that column real quick. It's skewed. It's definitely got a skewed thing. But I wrote down these numbers, right? 2 through. Based on the age category, these are all outliers. Not the 29, my bad. So I got it written down. I'm gonna come back over and we'll look at what we can do with this on a box plot. Alright, let me give you the instructions on how to do the box plot by hand. That way you'll understand when you're looking at it, what the fuck it is. It's a little confusing to look at. We're gonna need those numbers in a little bit, so I'm gonna keep them out. If you wanna do a box plot by hand. First off, you need the 5 numbers. It's also called the box and whisker plot. You'll see why in a little bit. Step 1, find 5 numbers. Find the 5 number summary. With that, you need to find the fences. Step 2, find the fences. Which means we'll calculate IQR at Q3 minus Q1. Also given to us by StatCrunch. Upper fence is Q3 plus 1.5 times IQR. And the lower fence is Q1 minus 1.5. That's IQR. This is now we've got all the numbers that we need, this is where we start drawing, so we're gonna. Draw a number line. That includes. In its range of numbers. The 5-number summary. And fences. And then once you've got that, like. Mark and label those values. Now for our box plot. Drawing the box. Big vertical lines above. Q1, median. And Q3. And form a box. That gives us our box, drawing the whiskers. We are going to connect. The lowest non-outlier. To the box. By a horizontal line. And then we'll do the same thing with the highest non-outlier. I like to think of this is like the house. And these are the fences which make the property. Property lines.
It's.
And outliers are not on a property. So for outliers. Off property. We put an outlier. Sorry, not an outlier, an asterisk. Where they are. Alright, that's a lot to write down. I'll let you do it, give you a little chance to process this. Then we'll do the numbers we have above by hand. Then we'll show you how to do it stack punch quicker. But I don't think you're going to understand as much if you don't do it by hand first. Yeah,
It's like first one, where the pages between rows one and 11.
yeah, these numbers right here, these are gonna be our outliers. And I'm gonna put an asterisk on them when I do it. Back on this page, I am gonna write. Lower fence equals 13. Upper fence equals 29 on the left. So that I can have my shit like that. When I do it. And I'll be able to look at my data and do it on the same page at the same time. If you do this by hand once, you'll like get a better understanding what the fuck you're looking at on a graph. Pie chart's kind of easy. Bar plot's kind of easy to look at. Box plot, you're like, what the fuck is this? Anyone need this up longer? Alright. So, it looks like my lowest number here is 13. And my largest number here is 51. So I'm going to make a number line. Maybe I'll put 10 over here. And I'll do like little increments of 10 going to the right. This is not set up well. Cause I got to 50 right away. Oh well, fuck it. Our number line isn't as long as I drew it to be. Eighteen is right about here, that's my min. 19 is right next to it. That's Q1. Fuck, 20 was the median. And since they're all so close to each other, I'm gonna write the numbers underneath them, what I'm doing here. Q3 is 23. And my max is 51. My fences. I'll do in red, this is my lower fence. At 13. And my upper fence right here is at 29. So I've drawn a number line with the 5 numbers and our fences, and I've marked where they are on the number line. So I can see more of that. What I'm gonna do is I'm gonna make a box out of Q1, which is right here. The median, which is. Oh, that's not Q1, that's the min. Okay, I'll do it below. Q1, the median. And Q3. Then we wanna do the whiskers, I'll do the whiskers in red. The whisker, we make a line from the left side to the lowest non-outlier. The lowest non-outlier is the min, so it stops right away. And the largest outlier or non-outlier was 29. That was my upper fence, and we had a score at 29.
So lower fence 13?
Yes. But we didn't have any values down to 13. So you'll notice. Your box plot may or may not. Have the fences marked on the box or in the picture. In the graph, I'll say. We happen to have the upper fence marked because we had a score there. But the lower fence is well past our lowest person. And then I'm gonna put an asterisk where the outliers are. We had one at 30. We had a couple we had one at 32. $35 had two. Stack Crunch will only put one there, but I'm gonna stack two there to kind of indicate it. So 30, 32, 35. 37 had three. Again, Stack Crunch is only gonna put one dot on there to indicate there's an outlier at 37. We have another one at 38. There's a lot of outliers here. 42 is past the 40 mark. And 51 is way over there. Generally. This stuff is above the number line. As you'll see it on Stack Crunch. So like this picture. Ideally, you're putting it up above, lined up correctly. So maybe if I do a small picture up there. So this is what we can expect to see on Stack Crunch. Minus that green crossed out line. Got handy dandy notebook. Thank you. She's like, I'm done looking at that fucking green line, get rid of it. Alright, in Stack Crunch. This is how we're gonna do it. You're gonna do graph. Box plot. You gotta select the column to graph. and check mark these two boxes, if there's still two boxes, they might have changed the way it looks. Graph horizontally, it's some variation of that word. And use fences for outliers. I might have the wording a little bit different than what it says, but we're gonna go look at it in a second.
Sorry, it's a little blurry on my end. The last part says use fences for what? Outliers?
Outliers, yeah.
Got it.
Should carry around a way out thing. Scribbling shit out just looks bad. I can't use pencil and erase because pencil, you will not be able to see it. Alright, you guys ready to go look at it, StatCrunch? Is everyone done writing down this list? Alright, we're gonna do share the screens. I'm gonna clear that so it doesn't show it, so. Graph. Box plot. Let's see, ages. Fences to identify outliers. I guess I had it closely to that. I said graph horizontally, they said draw boxes horizontally, we're gonna click on that. We'll click compute and. Doesn't that look a little bit like ours? I didn't put the little tiny vertical lines at I just put a whisker leading to it. These are called the whiskers, the things that stick out. When you're doing it in StatCrunch, you can always, since you probably do not want to do this by hand. If you want to identify stuff, you can put your cursor over it like an outlier and it'll tell you what the outlier is and what row it's in.
So when we're tested on this, are we going to be having to do it manually and through StatCrunch,
No, I'll have you do it with
or one or
StatCrunch.
the other? Okay, got it.
Yeah, this is just on the computer. But once you've done it by hand, like this, now you're looking at it, you've taken the time to mark these, now hopefully you'll remember, if you were following along and doing it, dots represent outliers. And another thing that helps, we can kind of identify the skew based on a couple things. First off, if a whisker and outliers is really a lot longer on one side than the other. Notice that I have a really long whisker. And if I drew a line all the way to the largest number over here, that's a really long line where the line going to the left of the box is short. Another way, oftentimes, it may not be as noticeable, there may not be outliers, but it can still be skewed. If one side of this box, there's a vertical line down the middle where the median is. If one side of the box is a lot wider than the other. If it's wider on the right, a lot wider on the right, like it is here, it tends to be skewed that direction. But you're kind of looking at where the median is, this black line, and going. How long is this area to the left, and then how long is this area to the right? And if one of them's a lot longer than the other, you say it's skewed in that direction. And I'll write that down in words on paper in a second. And we saw that, we can see that when we do a histogram on this. That it is definitely skewed. Okay. So, last bit of information, and then I'm gonna let you go. You got done early today. So like we had this. just a generic graph. I'm gonna say, here's our median, oh, that is true, that's our median. I'm gonna call this direction A. And this direction. B, I'll put another dot over here. If A is a lot longer. Not just a little longer, but a lot longer than B. It's skewed left. And if B is a lot longer than A. It is skewed right. I'm telling you that because I know one of the home problems, I will give you a box plot and ask you, is this skewed left or right? Or not skewed, it may not be skewed at all. Other than that, you are free to go, have a good day, get the fuck out. You might even have time to get home and not miss any of the debate, if that's your cup of tea.
I wait for the internet to tell me.
Right. I'm sure I'm gonna watch a little video of it, and then my wife is gonna say. Can we do something else? And I'll be like, yeah.
I was just